Hey, I'm Mike, and Ryan is with me here. We are working on finding a new business to build, a new tech business to build, and we ran into an idea generating SQL from AI that we want to walk you through. There were some interesting concepts and kind of learnings from it. But first, we'll give quick intros about ourselves, and then we can dive into the walkthrough. So, Ryan, do you want to go first?
Sure, yeah. My name's Ryan. I've been fortunate to be a software developer since I was a kid. In 2010, I started really getting into machine learning and have basically made that my focus since then. It's been fun to watch the field grow and progress. In 2017, I started a company that makes a hardware software product for DSLR mirrorless cameras. It's a lot of computational photography, machine learning AI on the hardware to basically help people take better photos. So I've been doing that, and Mike and I wanted to try to work together on something. So we've been searching for ideas, and this was a project that was fun to work on, but we ultimately decided not to continue with it. Mike, you wanted to kind of give a little background on yourself?
Yeah, sure. So I'm Mike. Similar to Ryan, been a software developer for a while since I was a kid. I was blessed enough to sell my kind of lifestyle plus business to Stripe a couple years ago. It automated a bunch of niche accounting problems for users. So sold that to them. Worked for Stripe for a while, and just recently left to build the next startup. So excited to work with Ryan on that. Um, so we're going to walk through this product. The basic product here is a search box that connects to your Snowflake account. So the idea was basically Google search for your business, where we would index your Snowflake account. And Ryan can go into more of the kind of AI side of what we did there, but index your Snowflake account, connect it to OpenAI in a smart way. So as you ask a question about your business, we do effectively a bunch of fancy prompt engineering and generate the SQL, run it, and show you the results. That was the core initial product we built. As Ryan said, we decided not to move forward with it, but it still works and it's pretty cool. And there's a lot of kind of interesting learnings, especially if you're getting into AI. So I'll kind of ask a quick question here.
Yeah, and I think while Mike's doing that, one of the interesting things, this is something that seems like a very, very simple product to build. There's actually a ton of engineering challenges to make this work practically. So it was a fun project to kind of, get to know how to feed data into these large language models. There were kind of some technical challenges just around what's valid SQL, how do you train? There's a separate model to actually decide what gets fed into the LLM. So a lot of interesting engineering challenges that really went into this to make it work. At the end of the day, the idea would be you enter a natural language question, it finds kind of the best query to answer that, and then the long-term goal was to actually add automatic kind of charts and graphs to visualize it, where there would be a separate model trained to predict the parameters as well. Currently, everything just kind of outputs in JSON, but the idea is really to be able to visualize. One of the interesting things is you can do some really complex queries, and if you feed in the right things in the prompt, GPT-4 especially is pretty good at actually generating the right results. Now, there's some work around if it fails, detecting that it failed, retrying, changing things. So sometimes you'll submit and it'll resubmit a slightly different query or a slightly different prompt to make that work. So, but yeah, it's the core functionality was there. We're open sourcing it, so you can take a look and kind of see all the challenges. We actually built this before LangChain was really anything. So there's some pieces that are kind of shared with LangChain now, but it was a good learning experience to figure out, all the challenges around that.
Yeah, it was amazing how much like the landscape changed just in the whatever month that we were working on this. Yeah, lane change didn't exist. Chroma wasn't really out yet, so we used the standard kind of Facebook face vector database. A lot of the problems we ran into with GPT-3, just kind of GPT-4 magically solved them. So we had a bunch of work we put into solving like SQL dialect syntax are, issues that just, we don't need anymore. So it was interesting just, when you're on the bleeding edge of something like AI, a lot of the engineering work just to get to kind of your first iteration just disappears in the next month because of all the other companies working on the same problem.
There was also every time we would go to do a demo, OpenAI would be down.
Yeah. That was also a big problem. But this was the core product. There was, you could view your history and some other kind of bits like that. There was a little admin panel we built, but we'd like to kind of mostly walk through the code and show you how it worked under the hood. We're going to post this code on GitHub so you can take a look. So just to talk through this stack, Ryan and I both hadn't used some of the latest hot JavaScript stuff out there. So the front end was built in Remix and Mantine, the React component library. We used this for the back end as well, but one of the interesting things we did that I'm still not sure was a good idea is we kind of split the back end into Node and Python. So all the requests initially kind of routed through the Node Remix backend and then hit a Python microservice effectively that handled all of the kind of AI, SQL parsing, all that kind of stuff. We use Postgres with Prisma, and the interesting thing with Prisma is there's a Python library that you can use to generate Python models from the Prisma database spec, which we found really useful to kind of specify the database model one place and then be able to use it in multiple languages. It's the Python library isn't officially supported, so we ran into a couple snags there and just rough edges. So still not 100% sure if that approach is really the best over the long term, but it was definitely interesting. And some of the Docker complexity that you'll see here and deployment complexity came about because we needed to generate the Prisma models across both stacks. We had Redis for some query caching and other cache needs. And then the whole system was built, for Snowflake explicitly, but with the idea that we could support Redshift and ClickHouse and the other kind of columnar databases in the future. But that's how it was initially kind of broken out. Ryan, do you want to talk about the Python side first, and then we can?
Sure, yeah. So the Python side, there were a couple of challenges. One, when we started, GPT-4 wasn't out. So GPT-3.5 was really good at generating Postgres style SQL. So it actually did not do well with Snowflake with the Snowflake dialect. So we basically started building a translation layer that we didn't end up needing once GPT-4 came out. GPT-4 is pretty good at generally pretty good. I would say there were probably 10 edge cases that we ended up correcting. So we used this SQL glot library that is a parser for all these dialects of SQL, of SQL, and it generates an AST of the SQL. And then let's see, Mike, if you want to go into, so that SQL parser is the main one. Let's see, and I don't know. Let's see, can I drive here?
Yeah, you can. Yeah, we're using live share, so you should be able to.
Okay. So there's kind of this core SQL resolve and fix. So this does a couple of things. There's a whole sequence of sort of manual transforms. Let's see. Forgive me, it's been a while since I looked at this. There's some manual transforms where we're basically sort of manually handling basically where common failure cases for OpenAI generating Snowflake dialect. So there's a bunch of those, and then once that's there, it goes into this SQL inspector. And what this is for, this is kind of interesting. There's two purposes to this. Basically, you're trying to figure out is it a valid query, and what would happen quite a bit is GPT would hallucinate columns or tables. So in order to know whether that's happening and correct for it, you actually have to be able to look at a query and say what are the columns and tables that are being accessed by that query. And the interesting thing in the SQL world is you that's not as simple as you might think. You actually need sort of a runtime evaluation over the query in order to know that. You have to know sort of what's the structure, and then you have to sort of runtime evaluate over the query in order to do that. So on top of once we had the SQL glot AST, I would actually there's actually a whole series of basically nodes that um, you need to sort of walk down the tree and recreate this other node structure in this particular order. So I had to kind of dig into the SQL spec to figure this out. Um, but if you go down this order and you build out these trees, you can actually create references to not only what columns and tables are referenced, but you can handle things like, oh, there's a subquery that gets aliased as a other table, and then that gets referenced. So we basically build up this little tree structure that points to, in the query, what are the columns and rows that are accessed, and what are they accessed through? So are they accessed through some alias subquery? Are they accessed through a join? Are they, And so we end up, I won't walk through the details of all this code, but we end up basically building up that little tree structure, and then we can use that to get what are the columns that don't exist. So once you have that, you can know whether it's a valid query, and if it's not, you can reprompt the GPT to try and get that. But the other value is you can only squeeze in so much. Like what we end up doing is we basically feed in some subset of the tables and row schema into the prompt. I don't know, Mike, do you want to kind of talk about that on that side, like what the prompt window challenges?
Yeah, totally. So the entry point for for kind of ingesting a database and indexing it is this importer file. And we like exclude a bunch of columns that are kind of metadata from various ETL tools. And then effectively we loop through all of the tables and all of the columns and then all of the data in those columns and create like a representation in our database for that. So we have the table column, data source table column here, and then data source table description. And these were the two main, the kind of two main columns here, or two main tables that all this data gets dumped into. Once we have all of that indexed, and there's a bunch of kind of logic here to determine which columns are useful and like what the cardinality is of various columns, and that helps us prompt GPT better. But once we get everything in the all of the tables and columns in our database, then when we actually prompt GPT, we effectively serialize our database representation out into a simplified kind of standard SQL format. And now I'm trying to remember where we did that. This has been a little while.
Yeah. By the way, I don't think the live share, you didn't see me changing files before, did you?
I did. Yeah, I have to switch. I have to like follow you.
Okay, cool.
Does that. So yeah, so this schema builder here, this is what takes our kind of custom database representation, custom table and column representation, and normalizes it into a kind of token aware version of the schema. So we really wanted to limit the amount of tokens on the GPT side that were used when we sent this over to GPT, and allow us to not just output the full table description, but like selectively pick columns that we wanted to include in the token window and do that. So that's what this schema builder does. So this is a place to look if you're looking for like, hey, how do you kind of generate a SQL?
Yeah, and kind of backing up on a high level, for most real world Snowflake databases, we can't feed in all of the tables and columns. The token window limit on even GPT-4 is too small. The other thing that we do, so there's a lot of questions. Like if you were to say, like how many of product name have I sold? Uh, it may not be aware, like if we were to just feed in the schema, it's not going to know that the product table and the name value on the product table, it might be able to guess that, but for a lot of schemas, it won't. The naming won't be enough to give it away. And so one of the things that we actually did was we took all the values in the low cardinality columns, so that the columns where you might have something like product names or anything along that line, state, country, whatever the format is. And we actually provided to the prompt what we called value hints. So the end result was basically you would put in a schema, and then you would actually like have the table column. So you'd say like, name. Yeah, Mike's got it there. So you'd say like name, text, and then comma, and then actually in an SQL comment, you'd say possible values include, and then you'd render these sort of string, or they weren't string matches. So I'll talk about that in a second, but these matching row values that it needed to know. And then what's great is in the final query, if I said like my current company's product is called Arsenal, if I said how many Arsenal 2s have I sold in the last year, it would actually say like from product where name equals quote Arsenal 2 in the exact format it is in the database. So that I think was a pretty nice little innovation to help. There's a lot of queries that follow that, a lot of questions people ask that follow that format. And so providing these value hints was pretty important to provide the right experience. And the way we actually did that, it's funny, this was a fairly novel technique 6 months ago, something I'd used years ago, but it's funny because I'd say even when we were doing this, the vector embeddings weren't a commonly known thing. Would you say that, Mike?
Right. Yeah, they got popular like as we were working on this.
Yeah, this is something I'd used on projects for years, but the we did end up using the OpenAI vector embedding, so you can feed it strings and it'll give you I forget how many dimensions it is, but a dimensional vector that represents X dimensions of sort of that text, and things that are uh, closer to it in space, in the vector space, are more similar. So we ended up building on top of Facebook's Face library, FAISS. It's a vector embedding library. I wouldn't call it a database because you build in batch, and you write it out to a file. So we ended up building on that. So there's a lot of let's see, where'd that code end up, Mike? Yeah. So if you go into the embeddings folder, you can um, see the different pieces to make that work. But yeah, basically we had some heuristics to decide which columns should be indexed. You would index them, and then in different ways. So you might index them where you'd say you'd have the table name and then the column name, so it can match on both of those. You might have the column name, table name, and the value hint, as we called it, which is a row value for a column. So we had kind of 7 or 8 of these indexes. And then the interesting thing is, once you had that, there was this optimization of how do you weigh these different results from the different versions of indexing it in order to produce the most effective prompt. And so I built this model that basically takes the uses the SQL inspector to figure out whether or not the column that we needed. So you could look at sort of a correct or incorrect generated query from OpenAI, and you could say, okay, for the correct ones, these were the columns that were accessed, right? So these are the row tables and columns that were accessed, and the column values that were accessed. And then we basically trained a model that learned from our kind of marking examples as correct or incorrect, whether or not the particular vector database was of the 8 vector databases we had was providing the correct results. And so we would basically encode the question, and then use this model to decide how to weigh the outputs of the various vector databases. And so it was a good way to basically improve the accuracy of ranking everything that could be fed into the prompt to decide whether or not it was, relevant and correct and useful. The nice thing is you do have enough window that you just need to get the things you need in the window. Doesn't matter kind of where they are. Like the language models are pretty good at getting that. Mike, is there any way I can kind of clarify that? I felt like it's a little
Yeah, I mean, the
involved.
thing that comes to mind for me, I mean, most of the logic was in the ranker folder, right? In terms of actually training the models that we run locally on our box. And then there's a file here that actually ran the model. Was it all in this ranker folder, Ryan?
I think so. It's
Yeah,
been a
it's
while.
been a little while.
Yeah, the idea is we train a local model to rank the outputs of these vector searches in order to decide what columns, tables, and rows should be in there, like what the priority of columns and tables and rows should be. And that pretty pretty dramatically increased the number of times the correct columns and rows, sorry, the correct columns and tables and value hints ended up in the prompt.
And the main thing that you're fighting against is just the token window. So as the token window expands to like 32K or 100K for some of these recent LLMs, I think this problem becomes less important. But still, with our beta users, we had hundreds of tables, some with 100 columns or something like that. And so there's just no way to pull all of that, including the few shot examples, which we wanted to include in the prompt as well. So you're always kind of trying to determine what the best schema pieces are to include, and not just on a table level, but a column and a value hint level. So this was largely to kind of work around all the token limits, which still exists. And I think this approach worked pretty well for us to have, as Ryan was saying, this local model to kind of pick the optimal priority of the various components of the SQL schema, and then the schema builder actually kept track of the available tokens.
Yeah, it would take in a ranked list of tables, columns, and value hints, and then take in that ranked list and then basically produce the prompt keeping track of the token count. What was our issue when we would always end up over or under tokens on this, and we had some bug that took us a little while to figure out. Do you remember
Yeah,
that?
I think there was just some bugs in this logic at first. We also felt as though the OpenAI like token counting was slightly different from the library we're using. And the library we used, I can't remember the name now. I think it's like Tiki
Yeah.
token or something.
It is OpenAI, isn't it? But um,
It always seemed to be slightly off from what actually OpenAI spit back. I don't remember what the other issues with it were.
maybe they don't count maybe they don't exclude, like the 8,000 includes their preamble or something, or their system
Oh,
message
interesting.
or something. I don't know. Anyway, that's probably fixed by now, but at the time it was an issue. So um, yeah, so that's the general idea kind of on the product as a whole.
You should chat about the few shot examples. I don't think we ever got to actually building that.
No, I got a little ways into it. So, yeah, so one of the other things that we wanted to do is there's a lot of what would you call it, like industry jargon where they use terms that are just specific to their business and OpenAI can't guess at it. And so the solution to that was basically as people went along, they're going to mark questions as correct or incorrect. And for the ones that they ask that are correct, again, we have a vector embedding database where we're actually embedding the whole question. And then we're matching to similar questions that they've already asked and feeding those in as few shot examples. And I do think we got that working, didn't we? Or we got to that. Um, And that basically is following, you're just providing that as an example in the prompt, kind of picking how many of those you want to do. So that again, I think that there was more we wanted to do, but it was literally just questions match based off of vector distance, cosine distance, and then would input a certain number based off prompt window size constraints.
And I think the questions were marked as correct either by us or by the user, so we knew they were good examples to include. So that's where the kind of feedback loop of getting feedback from users, and just internally we had an admin to kind of pick questions that were good, that kind of helped feed into the few shot example database. But I think that's most of the backend. The other thing that was kind of interesting was where is this thing? Yeah, there's a bunch of code in here to deal with, like, should we use the chat model? Should we use GPT-4? And we kind of kept testing out these different models. Yeah, the OpenAI throttler. People might find this interesting. This was very tricky, and it probably still is an issue. Hopefully less so than when we were actively working on this. But OpenAI would go down all the time and had all sorts of errors that would pop back up. And there was lots of different kind of limits that we needed to deal with. So there was like the embedding token limit, the codex token, and then just the number of requests you could make. And we couldn't find anything out of the box that kind of did all of this rate limiting for you and did kind of sane retries when you encounter different failures. So that's what this OpenAI rate throttler did. Is it kind of dealt with all of these various limits, kept track of all of them, and then there was this context manager piece. It would retry specific types of errors and back off on them, which was kind of neat. There was this was actually harder to figure out than we thought, is actually using this back off library, but only backing off on particular error types and only a certain number of times, and still requesting token limits or still respecting the token limits. So that was kind of interesting.
This was we only worked on this for a couple of weeks, but this went through 3 or 4 iterations to get everything working.
Yeah, it was harder than we thought to just even there was all these OpenAI reported different things than actually seemed to align with reality. So there's some buffers in the code to just get it to work, even when the numbers came back correct.
It seemed like too at the time they would throw rate limit errors when they were overloaded, not when you were over your rate limit. Is what it seemed like for a while. So
yeah,
it was definitely things are a lot more smooth now, I would say. So
so yeah, the only other piece is that basically this all was exposed through a really simple HTTP API, and this was the entry point on the JavaScript side. Yeah, anything else on the Python side, Ryan?
No, the SQL inspector stuff's pretty interesting. I think I'd like to, when I get time, open source this as a library. There really was nothing out there that I could find that would kind of give you this like runtime evaluation of a query that wasn't like embed the Postgres query, like something that was fairly easy to set up. So it was a good learning experience to kind of figure out how do you actually like what I ended up building is basically a very simple runtime evaluator for the SQL that only is trying to create this tree of what columns get referenced in what parts of the query. But yeah, a little harder problem to solve than you'd think. You wouldn't think you'd need to build a full basically a full query parser plus not just the parser, but the actual what part of the chain would you call that? AST runner, basically.
Yeah. Yeah, because I thought the interesting thing that you wouldn't think about when you're considering kind of SQL is you can get SQL AST, but to know if it's valid or not, you really need to know the state of the system that the AST is executing on.
Yeah.
So you need to know the tables and the columns and indexes and all the details to actually validate if the SQL is valid and even interpret it correctly.
Right.
So the AST SQL stuff out there just didn't do it. I mean, Ryan,
Yeah.
you did a really
With the aliases and stuff, you need to know, yeah, you can't look at just the query and know whether it's a valid query. You have to know what the schema is. Um, so it was kind of interesting to try and build those pieces in a pretty short period of time. So, but I think it's pretty useful now. Now we have something that can take in this simple representation of a schema and tell you whether it's a valid query or not. There's still maybe a few nodes it doesn't handle, but generally it works. I used Python 10 plus has the pattern matching, made it so much simpler to do that.
yeah, that was cool. Where
Where
was
was
that?
that? Is that in the builder, SQL builder, I think? Yeah.
Yeah. Right.
So there's yeah, just kind of this big pattern matching on being able to just like succinctly pull out. I mean, I've used pattern matching before, but not in Python. So it was nice to be able to pull out, the pieces you need from the SQL GLAT AST. And then the other interesting thing is just that when you're building something like this, it's all about the order that you parse, how you walk down the tree. And it's really interesting because it is not a like left first or right first. It's again, somewhere in the docs I have it, but it's, froms go before I think it was yeah, it's like you have to do it in that order. And so being able to, like your froms have to come before your joins, and if you get any of that wrong, it doesn't work right. So the real trick to kind of parsing to runtime evaluating SQL is knowing that order, which isn't really listed anywhere. You kind of had to dig through, figured out partly by experimentation and partly by I looked at the spec, like sort of the ANSI spec, and it's not clear from looking at that this is how you would do it, but that strategy seemed to work pretty well. So
Yeah, you did a ton of really cool work here. I really hope you get time to open source it.
yeah, I'd like to. It's it's useful. I'm sure someone would find it useful. If nothing else, if you're building something similar, again, being able to runtime evaluate whether you've got a valid query and whether you have not only whether it's a valid query, but sort of what's the chain of where columns go and what they end up. Because we actually needed to know there's a lot of like disambiguating columns. So you might have a query that's got multiple, you could say like select name from table 1 comma table 2, and looking at the query you can't tell which of those has name in it. And there's a lot more sort of contrived examples where um you've got multiple tables through a join, and you need to figure out like which table actually has that in it, and walk it backwards through these aliases and joins and things like that. So that the end result that we needed was give me a query, give me a schema, and tell me which columns and tables, and sort of we also did like string matches and in matches on columns, and that was sort of for value hints. So you could figure out, specifically which row in a column were you matching against. So yeah, so it's yeah, it was a fun little thing to experiment with and try to write in a short
Kind of
period.
cool. I mean, we solved like a really a number of interesting problems pretty quickly, which is
Yeah.
fun.
Yeah, this was like just kind of recapping too, I would say. This is one of those things where I think you see the product now and you're like, oh, 5 minutes, But it was a good we kind of knew, I think we knew going into it what to expect, but there was a lot of engineering to actually make this work well. Like, and it was fun because as you build it, you kind of add things, and the rank model the local ranking model was like a huge win to get more, and basically you're just trying to up the number of successful queries. Mike, do you want to talk about like, one of the challenges I think you do end up with a product like this is just there's always going to be questions where a non-expert human couldn't answer, right? Like, and so I don't know, like what's like, I think the chat interface is like the next evolution of this, where you're sort of having it clarify what it thinks is ambiguous and things like that. It's interesting because when we started there was no chat API, right? So
Yeah, and what I remember us considering like, hey, when you input a question like, where do most of our customers come from? You could kind of store a database, vector database of related questions, say, hey, you might want to say what state do most of our customers come from in order to get like um, actually pull out a US state and kind of list out prompt suggestions below. There's a bunch of things we could have done to kind of hint the user towards the right direction or help them explain their internal jargon, as Ryan was mentioning. Like some users would store like the brand in a column in their database that was not named brand. So you could ask them, hey, we can't find anything that looks like brand in your database. Could you point us to where that's
Yeah,
actually
that
stored?
was one. They said, I think they said vendor in the question, and that was brand in the,
Yep.
which was far enough away, it couldn't figure it out. Um,
Yeah.
yeah, it was an interesting, it was a good, really good experience working on it. I think, I would say too, we're going to open source this, give it a try. Like it's pretty cool. I think one of the most interesting things is just how complex of questions. I think Mike, you and I were even kind of surprised at one point by how complex some of the questions and some of the generated queries could be, where you'd say, how many Canadian customers who spent more than $100 and returned to buy X did this, like you could really get some pretty complicated queries at the end. Um, and I think, the potential's here. I think, we decided not to continue with it, but I think, if anyone wants to pick it up and run with it, happy to help them, you know, keep going on it. So, if nothing else, I'll use it for my other company.
Yeah, it really, there's been a couple of times where like, man, I don't want to write the SQL for this question. I want the system to. So it really worked well.
Yeah.
I want to walk through the front end side. This is my first time using Remix and TypeScript on back end. I've done some React work in the past, but so for me, it was a big learning curve. But I overall really liked Remix. The interesting bit about Remix that I learned that you obviously can read this in the docs, but the kind of if you're coming from a Rails background like me, you normally have like an MVC model and you have a controller. The routes just kind of point to what controller you're operating under. But in Remix, the controller actually renders the view. It's kind of the view and the controller and the route kind of all mixed into one. So you have this action method and this, which is if someone kind of submits a form, it'll call this action. And then you have a loader method, and that kind of loads the data right into the front end. And you don't need to write an API. That was kind of the magic of Remix, is you just specify this loader method, return the JSON right here, and boom, you have this magically in your React component down below. So that really saved a lot of time and allowed us to iterate really quickly. We were both really disappointed with the state of just kind of a lot of the pieces of the JavaScript ecosystem, particularly Prisma. Like Prisma was fine for generating SQL and running migrations, but it's not an ORM. It just runs queries through a DSL, which is nice, but there is effectively no ORM in terms of actually getting a record back, being able to mutate it, and then saving it. That's not something Prisma does. It doesn't do any sort of data validations, which made it kind of unclear exactly where that should go. So that was one of the challenges that we never fully solved. Like there's Zod here, as you'll see in a lot of the front end, which does the kind of input parsing.
And back end, right?
And yeah, exactly. The back end as well. So this did the input parsing for the input coming from the front end to the back end.
That was one of the nice things, I think, with Remix is, if you're writing this sort of data validation code, you get it on the front end and the back end. So the front end can kind of easily react to, update the UI for error state, and then the back end you get, without writing it twice, you're getting the validations and the security side. So that's pretty nice, I would say. And kind of the RPC back in, like instead of not that making the rest like a REST API is hard or something, but you basically get it for free in Remix, which is nice. And I think Next has adopted kind of a similar thing since we started. Um,
And the other thing along those lines that's nice is all the types flow right through. So you return this JSON, and the types that are specified on this variable magically show up in your React component. Which is, you could get that if you use a microservice architecture, if you use something like an open API spec, but it's much harder, and it really allowed you to move very quickly. Just having this all built in. Mantine was also really nice, really impressed, especially coming from big tech where they have all, a component library in-house that teams of people worked on. Mantine was really good and kind of matched the quality of the kind of in-house component libraries that I've seen at big tech companies, which was really neat. One thing that we did that was a little interesting is we had this lib folder, and we had sort of I called it back end to the front end, which is probably a terrible name for it. But effectively, all of the front end routes would hit these different dot server paths, which locked the code to only being available on the server side, not on the front end. And at the end of the day, this boiled down to making a Python request for us. So we tried to keep the kind of back end on the node side really thin, largely because we found that the dev prod kind of state on the node side is still pretty bad. There's not a really great REPL. You lose stack traces in some libraries. Just the quality of a lot of the libraries used for backend code seemed pretty poor. And we needed to use Python for the machine learning side anyway, so we just decided to kind of move as much of the back end logic there as we could, which was interesting. I'm trying to think of the other. Oh yeah, anything else on the front end side, Ryan? I'm trying to think. It was pretty straightforward.
yeah, just there's a lot of good component libraries now. So a lot of good.
It's so fast to work in. It was really nice.
So, yeah, and I think I really Remix makes, like, I don't think we had to think about sort of bundling up our assets once, like it just kind of handled it. So that's great. Like where and I think now that ESM is more fairly established, like we didn't run into too many issues with, CJS libraries or anything along that line. So
yeah, it really felt very, very smooth once you kind of develop the boundary between the Python side and the JavaScript side. It felt like we could move really fast. I do remember there was bits around like, sentry tracking kind of things that shouldn't have. So if you're looking for like sentry integration, and there's some good like logging stuff we did in terms of like structured logging and levels and all that kind of stuff. So yeah, some interesting bits there that might be good to look at too. Cool. I'm gonna walk through the Docker side. Is there anything else? I'm trying to think. So I heard about Fly.io. I love their blog posts. They do such a good job of writing their blog posts, and keep nerd sniping me to wasting 30 minutes of my time reading about all these esoteric topics. But so I really wanted to try them out on this project. I was kind of disappointed. I mean, on the one hand, it's a really powerful tool that it was pretty seamless to get it to get the initial version of the application running. But there's lots of kind of sharp edges that you wouldn't expect with Fly. For instance, like logging, sometimes it just drops random log lines. It would go down quite a bit. There was strange things like you couldn't modify the secrets in the UI. You could only modify them on the command line, and same with DNS. There was some strange kind of edge cases, which made it, which kind of decreased the enjoyment of using it over time and made it more frustrating. I honestly missed Heroku by the end of it, as much as I've learned to. I still love Heroku. It just hasn't improved that much, and I really wanted to use something that was improving and changing, but it just felt like Flyo needs some more time to bake. That being said, great for hobby projects. And the thing I did really like about it is you could deploy kind of customized Docker packages, really easily. So there's a little README here that walks through what's happening here. What I did, the challenge that we had is we had to deploy the node and the Python side. separately, but the database there was a shared database and shared Prisma schema here. And the Prisma schema required on the Python side the node package to be installed in order to generate it. So you'll see these 4 steps here, and now I'm struggling to remember exactly. Yeah, so it's there's 4 steps, and if you look at the Docker file, you'll see how these kind of, so the Docker file is very slim, and this Docker file is heavily modified from the example and the kind of bootstrap template that they gave us. I thought this approach was much cleaner and reduced the cycle time when you're doing new deploys, because if you modify aspects of the root Docker file, it can take a long time, on the order of like 10 minutes to run a new deploy. And this got it down to like a minute or 2, which was totally reasonable. And so what this does is, and the other bit here is we used ASDF for all the version management across, Node and Python, and Poetry. And so what this did is it first kind of ran this install script. And this install script basically installed the versions and ASDF that we want to use for Python, Node, etc., and a set of command line packages that we wanted installed. So this is a really nice thing about Fly.io compared to other kind of PaaS providers, is you can add in all your favorite terminal utilities that gets built into the Docker container that's run in production, and then you can SSH into those containers and work like you would on your local machine, which is really nice. So installs this list of utilities here in this install step, and then it goes to the I can remember to the package step, which basically installs all the Python or Node packages. So on the Python side, this was a little tricky because we needed to install, Node, NPM, and then only install the Prisma library, so that we could generate the Prisma package for Python in the run step, or in the install step, which is next. So that's what this does right here. And there's some interesting bits in the shared folder here around like extracting the version of Prisma from your package JSON, your npm package, and extracting the npm version from your package JSON. It also pulled from the I think the tool versions file as well in another area. So there's some neat pieces here around extracting the versions from your configuration files and using that to generate the Docker image. So,
Mike, what was your take on sort of, because one of the challenges we had is we had a lot of Python packages that were, like we had PyTorch, which is always a decent amount of time to build. Like what was your take on sort of this versus like traditional build pack Heroku style? Do you feel like the Docker Docker setup is a win?
I think the trick is like, I would much rather use just a Heroku build pack with the, for instance, thanks for bringing up the let's see if I can find it, the PyTorch stuff, because that was especially tricky because you have to use these particular like download files. I can't remember why. I think we had like CPU versions locally.
Yeah, it's getting the, like, we're working on a Mac, so it's like getting the local Mac build version versus the non-GPU version for the server. And I forget why there's a third one.
And for some reason this didn't work. ARM
versus x86. Yeah.
Right. Yeah. That was the other bit. And just referencing Torch or PyTorch from your standard Poetry dependencies just didn't work. So we had to specify these kind of individually, and these are huge packages. I don't know if this would work with an out-of-the-box Heroku. The other thing, or build pack,
over the slug size on Heroku, right?
I think so. And I think that's one of the main benefits of Fly, is even if you're on a smaller plan, they give you a pretty big builder machine to work off of. And so they'll actually build the whole thing remotely. You need to use your machine, which is nice. And they'll register the image in their kind of private registry. The other thing that I think would be hard to do with, hard to do with like a out of the box build pack is the, let's see if I can find that here, but the, the Prisma generation. So I think if we didn't have the Prisma, if we weren't using Prisma on the Node and Python side, I bet we could have used a more out of the box Heroku. I mean, obviously you can modify the build pack stuff. It's just generating Heroku Docker images behind the scenes, but I've done that before, and this felt slightly better because you have more control over the stack, given that you're doing enough custom stuff. But
one of the interesting things with Prisma, and I don't know how I feel about this, but they actually they take your schema and they generate like a local node package or Python package. And so that's why you need this build step as opposed to just they're like basically generating a one-off client library for you based off your schema, which is kind of an interesting idea, but it made the deployment harder, I would
it made
say.
local development a pain. That caused us like the most. Remember that day we just like banged our head against the wall trying to get it to work properly?
Yeah, yeah. Well, there were definitely a lot of issues between the Python, but even on just the Node side, there were some issues, which we were able to work around. But it was, it's an odd. I'd say it's kind of an odd optimization or whatever you want to call it. It's an interesting choice, I guess. And maybe that's so they can support more static languages in the future or something. But feels out of place in the Python and the Node ecosystem, right?
And it made the build, like the whole build deploy process, much more complicated. So I think if you didn't use Prisma, it would be easier to get away just with using a standard deploy.
To be
Uh,
fair, it was nice to have kind of the basic schema accessors
yeah.
in Python and Node. The challenge is just then you have to watch your logic, without sort of a standard model in place. You kind of have to make sure that you're syncing your logic between the two. Although we didn't have a ton of sort of business logic to worry about, but I think if you had
But if we did in the future, that would have been a massive pain.
yeah, we kind of knew that going in that the business logic is pretty minimal on this product. So
So yeah, this is the Docker side. There's the two Docker images, Dockerfile Python, and then Dockerfile Node. They both basically look the same. They hook up to the TOML files here. And you can kind of see the reference there. So the deploy, another interesting thing was the GitHub Actions workflow. We got this almost fully automated, I think, if I'm remembering properly, where there was a separate node in Python GitHub Actions, but it ran all the tests and actually deployed through FlyIO at the end automatically, which was really cool. And this worked well. So that was neat. And there's some interesting bits here around like, setting up Python with the right versions and like a bunch of stuff we did for caching and all that stuff. Anything else coming to mind? I think that's most of it.
if someone wants to try and get this running locally, what do they do?
Oh yeah, good question. So the README is decently documented. There's a setup script here that walks through kind of everything you need to do, like installing all the ASDF packages, like setting up Poetry, a couple other like random dependencies you needed, and running the migrations, that kind of thing. So you'll run this, and then you'll need to import a database. Let's see if we can find that. So you need to import a Snowflake database here. And then you should be able to, after you import it, ask questions through this, like either the HTTP API or this little, we added a couple CLI tools for this. If that works for you, then you can start up Remix, and it uses all of that stuff is in the package.json. You can just use npm run dev, and this should, since you already ran all the migrations using the setup script, this should start the Remix server, and you can kind of play with it from there, assuming that you have a database imported. To set up a user, there was a console command for that. Oh yeah, there was this the console file has some interesting pieces here trying to like improve the default node REPL with like copy to clipboard and getting a class name. So some interesting things there. But there is a helper somewhere, create user, that you can use to create a example user and then log in on your local machine. So I think, oh, do you need to train the ranker? I think you do actually.
Yeah, I think you do. Yeah, I'll update the README on that. But yeah, it's in the towards the bottom of the README.
Isn't
Uh,
it? Is it this? The enable ranker?
uh,
That's just to run the server.
there's this train only.
Here it is.
These ones. I don't know what. I'll have to look and what that line was. I don't remember.
There's yeah, you had to build.
That's the few shot. So you have to train the ranker once you have it hooked up and do the few shot embeddings.
And then you should be off to the races.
It does take a while to run depending on how big your database is. And watch, we make no guarantees on Snowflake costs.
Yeah,
Good.
Snowflake is not cheap. It's a great business.
But yeah, if you run the train the ranker and then train the few shot embeddings, or build, sorry, not train, build those two. But yeah, thanks for watching us walk through the code. Happy to answer questions about it. It was a fun project, and we're I don't know, we want to talk about what we're doing next. I don't know. I don't know if we know.
We don't know exactly yet, but we're on the hunt for the next big idea. Probably build another one of these projects, see where it goes. But yeah, if you have any interesting ideas, feel free to reach out. We're always open to chatting. Awesome.
Thanks, everybody.